Hey guys, my name is Anthony, and today we are going to be reviewing some trigonometry. So the reason I wanted to do this video is because one of the problems I see with a lot of the students early on in the class is they don't, they're a little rusty on their basic trig. So today we're going to do that, hopefully, to get you caught up on that trig so you don't get behind at the beginning of class. So let's just jump right in. I'm pretty sure most of you have already heard the SOHCAHTOA thing. It's just an easy way to remember the very basic principles of trig that we're going to be using in this class. So let's write it up on the board. We have SOHCAH and TOA. Okay, like I said, you've probably seen this before, but what does it really mean? Well, if you look at the first letter in each of these, it is sine for S, cosine for the C, and then tangent for the T. And here we always put this theta right here. And theta is our angle. So whenever we're working with these, we're using angles. Okay, so that equals O stands for opposite, H stands for hypotenuse, so opposite divided by hypotenuse, and then cosine is adjacent over hypotenuse, and we'll get into what these mean in a second here, get a visual representation, and tangent equals opposite over adjacent. So these all refer to basically just a triangle. We have our triangle here. What we have is the longest leg is always our hypotenuse. And let's say our angle, theta, is right in here. It measures the angle between this leg and this leg. So this one is our adjacent, and this one is our opposite. Get a better A there. Okay, so the reason it's called opposite is because it's opposite of the angle. And adjacent, the angle is touching the leg. Anyway, so what we have here, say we have a 30 degrees here. Well then, our sine of 30 is going to equal our opposite over hypotenuse. Now, the biggest mistake that I always see is people thinking, well, let's put this on a plane first. So if we have our x and our y, then we have our force coming out this direction. Say we have 30 degrees right here. This is what we're going to be looking at in the problems that we're going to be doing. So what we can do is draw a line down, and now we have a nice triangle. Let's say our hypotenuse, we're given a force of 30 pounds. And now what we want to do is find this component. So right here, this leg of the triangle and this leg of our triangle. So the x and the y components. Going back to the biggest mistake that I always see is people think that the cosine always gives you the x component and the sine always gives you the y component. Now, for what you've done in your math classes, you can say that about 99% of the time and be okay, because you're usually always measuring your angle off of the x-axis. But that is not true in this case. We have to be very careful that we're always looking at opposite and adjacent legs. So let's get another example on the board. And this will show us why that's not always true. So now say that our 30 degrees is up here instead of down here. Well, you finish off a triangle, and if you look, this is now the opposite leg. This is going in x direction, so that's our x component. So x in this case equals sine of 30 times 30, which is our magnitude. And we can get that, I'll just show you really quickly. If we have sine of 30 equals opposite over hypotenuse, well, we know our hypotenuse is 30. And just doing some algebra, we get 30 sine 30 equals opposite, or x in this case. And then if you want to get the y component of this, you just take cosine, we'll do 30 cosine of 30. And that will equal the y component. Okay, so it's always very important to not mix up your sines and cosines, but keep those straight and make sure you're using the right one at the right times, because that will change on you. The angle won't always be measured off of the x-axis, so just something to be careful of. Okay, so one other basic thing that we need for a trig review is the Pythagorean Theorem. So if you remember that, get a triangle back up here, opposite, adjacent. I'll just put in theta right here. So the Pythagorean Theorem states that h squared equals a squared plus b squared. So this is really helpful when we don't know anything about the angle here. All we know is either our hypotenuse and our adjacent or opposite leg. Or we don't know our hypotenuse, we don't know our angle, we just know adjacent and the opposite leg. So let's see how we can use this to find, basically what we're missing. I'll leave that up there. Say our adjacent leg is 3, and our opposite leg is 4. So what we have now is h squared, and we're trying to find our hypotenuse for this, equals 3 squared plus 4 squared. Okay, so after that we know this is 9, we know that's 16. So h squared equals 25. Solving for h, we get the square root of 25. So therefore h equals 5. And from this, we can now go on and find this angle right here. So let's do that. Let's just use sine. So we know that sine of theta equals opposite over hypotenuse. So 4 over 5. So to solve for sine, to solve for theta, we just use the inverse of sine on the other side of this equal sign. So we get rid of the sign over here and we say theta. Let me draw a better theta. Theta now equals the inverse sine, that's what this little -1 means, inverse sine of 4/5. And that will give us our theta. So all of these, sine, cosine, tangent, inverse cosine, inverse sine, inverse tangent, they're all just functions that you'll be able to use on your calculator. We're not in the math class. We're not going to worry about learning the circle. We're not going to worry about memorizing all of these different angles. So just plug them into your calculator and go from there. Anyway, that's it for the trig review, and we'll see you next time.